Number 21. This one going to look like this. We're going to start here at -1, down 1.5. Got that slope. Again, these are points you can pick right up off your, and we'll go 7. Points you can pick up off your calculator. This graph's going to look just like this. My vertex, of course, is at 0, -1, and my AOS is going to be x equals 0. Let me identify this. This is your vertex, and then your AOS is going to be right there. So on this one, your vertex is right here, and your AOS is going to run right down that y-axis. Both of these, this is a max highest point. This one is a max highest point. This last one, man, pull these points right off of your graph. We're going to have, what's that going to be, -3 and +1. So this point's going to be right here. You'll have your vertex. It's a great way to pull it straight off your calculator. I'm just plugging in some numbers. You will have, what's that going to be, -1, -4 for your vertex. It's going to be a minimum down here. And then we will have x equal -1. So this is all calculator work. You can do this by hand like I'm doing, but it's much better for you guys to grab it off that table. You don't want to pull it from the graph. You want to pull it from the table of your calculator, not that graph. Get yourself some accurate points. Make the marks. Once you make the marks, the vertex is very easy to find. Most of our problems, your vertex will be pulled straight from the table. Some problems you might have to calculate that vertex, but we're going to try to keep those to a minimum. All right, the word problems. This is where it's going to get a little more aggressive. We've got Daredevil Jeff Gravity Hotspot Jones. Just hired you to be a math whiz on his staff. He's going to jump his rocker-powered tricycle over a 7-Eleven. And we want to calculate that height, see what his flight path is going to be. And the first thing I'm going to do is take this and I'm going to drop it straight into my calculator. We'll see what happens. So I've got the +4x +10. Now you'll notice when I take this and drop it in my calculator, the first thing I'm going to do is go to my graph, and surprisingly, it's nowhere on my graph. Oh, there it is. There it is. It's going to go up, and then it goes right off the graph. So I'm going to go into my table to see if I can find a good window range. I'm looking at my table, looking at the y value. So as he goes, of course, he's going higher and higher into the air. He gets about 30 feet in the air, and then he starts coming back down. You'll notice that y value. This is him coming back down. And at 23 feet, we've got a negative y value. So what I'm going to do is I'm going to change my window. We're going to start x0. The max x, he landed at 23 feet, so I'll go to 25. X scale, count by 5s. My y minimum, 0 is the ground height. He got 30 feet high, so I'm going to go 40 feet in the air. Counting by 5s, again, not a bad day. And now I'm going to hit graph. So this, looking at the table, allows me to get a pretty good estimation of where he's going to go. This is him jumping off and then landing. I'm going to go back to my table to get some good points to graph from. 2010 was a good point. 21, 5.8. I'm going to get that 30 because you'll notice that's the vertex. It's balanced on each side. So I'm going to get 10, 30. Continuing on, of course, I'm going to get 0, 10. My starting point. That's a handy point to have. I'm going to look for a clean number. How about 3 and then 20.2? On my graph here, I want these points. I'm going to count. I'm going to go 5, 10, 15, 20, 25. Oh, that's too much. We're going to go 10, 20, 30, 40. And over here, I need to get to 25. So 5, 10, 15, 20, 25. That'll work. I start here at 0, 10. My next is going to be at 3, 20.2. My next is going to be at 10, 30. And then I've got 2010. And then I'll have 5.8 looking just like this. It's going to come up, and then he's going to come right back down. So maximum height, that's going to be your vertex. It was right here at 1030. It was a great maximum height. Why might that be important? Well, if you're jumping over a building, so after 10 feet of horizontal travel, he's 30 feet in the air. if you're jumping over a building, that is the maximum height you're going to clear. So, building cannot be taller than 30 feet. So the building must be less than 30 feet, or you're not going to clear it. In fact, it's got to be even less than that because you're only at 30 feet for just a little bit. This one. How tall is the ramp that Jeff is jumping off? You'll notice at time 0, when he leaves the ramp, he's 10 feet in the air. How do I know? This is his starting height. When he leaves, he's at 10 feet. Assuming Jeff is landing on another ramp of equal height, how far away does the other ramp need to be placed? Well, at 20 feet, he is at 10 feet in the air again. So if we have the same height on our landing ramp as we do at our starting ramp, it needs to be that far away. And this is that problem. So if you think about it, we've got our ramp here, and we're going to want him to land right there. So he jumps 30 feet in the air. Here's our building somewhere in the middle. If it's got some kind of radio tower, then that radio tower cannot be any taller than 30 feet, or he's not going to clear it. And then our final ramp right here at 10 feet to land. And that's his problem. Let's move on to our last word problem. Due to an unfortunate misunderstanding involving jar of mayonnaise, Timmy finds himself forced to use the ejector seat in his car. His height at any time can be given as this, where x is the time in seconds and y is the height in feet. So again, going in, I'm going to take, and what we got, 20x. This is my graph. You'll notice, again, I go off the graph, come back down. So looks like my x is too big, but my y is not big enough. So when I go into my window, I need more y value. You can go into your table. I'm just going to go 100. Count by tens. My x values can come down. I'm going to come down to 15s. Count by ones. And here's my new graph. So he's going to go up in his ejector seat, and then he's going to come back down. Now this is time, and this is my height. So now I need some good points for my table. Gonna go here. Of course, if you come out of the ejector seat, you're on the ground. So at time 0, when it first fires, you're going to be 0 feet off the ground. I want my vertex, so I'm looking for a place where it's balanced. If you'll notice, at 5 seconds, we're at 50 feet. And then at 4, we're at 48. And at 6, we're at 48. So 50 is going to be that exact middle where it's nice and pretty on both sides. And I'm going to pick some other. I'm going to go 1 and 18. And I will go 9 and 18. And I think 10 will be at 0. And that'll give me a super nice one. I'm going to cut the video here. We'll make one more. We'll make one more to finish this problem.